The sliding window algorithm is an algorithm used to solve string, array, and sometimes even linked list questions. This algorithm allows you to find or calculate something within a subrange. Usually the sliding window approach is used to find the longest or shortest sequence of something that satisfies a condition. Before we get started, please like and subscribe to see future videos. So, how do you know when you should use the sliding window algorithm? Look for the terms minimum, maximum, longest value, shortest value, case size value, or the word contiguous. If you see these words in the problem, then you should probably solve the problem with the sliding window algorithm. The benefits of using this technique is most problems can be solved in O of n time and O of 1 space, and this technique is used to avoid the brute force nested loop approach. When setting up your sliding window algorithm, you're going to have two variables, one that signifies the start of the window and one that signifies the end of the window. Let's look at the problem maximum sum subarray of size k. This is an easy difficulty problem. So given an array of positive numbers and a positive number k, find the max sum of any contiguous subarray of size k. So what do we know? We can't skip any values in the array, and we also know what the length of the subarray is going to be. So we already know the size of our window is going to be equal to k. So right here we have our input. We have an array with these values, and our k is going to be equal to 2. So first, we're going to want to keep track of our current sum. So let's write that first. So we're just going to put our max sum down here. I'm just going to call it max. So this is what our max is going to be throughout this. Now, let's also write out the array so we can just kind of look at this. So we're going to have 2, we're going to have 3, 4, 6, and 5. Now, the start of our window and our end of our window are going to both begin at 0. So let's put start and end. We are also going to want to have a current sum. So this is the value that we're going to hold, and we're going to compare it with our max sum. So we're just going to put current. What we're going to do first is add that end value to our current sum. So the end value is 2. Right now, our end value is still not larger than our k value of 2. We're still at the first spot right here. We still do not have an array that is larger than that total size that we're allowed to have, which is 2. So because of that, we're going to move our end 1 forward. So n moves forward 1. So now that we've moved n forward by 1, we're going to take that value, which is 3, and we're going to add it to our current sum. So our current sum is now equal to 5. Now, our end is going to be at a point where it's now equal to the size of the amount that we're allowed to have. So we're allowed to have 2 distinct numbers inside of the array that we're allowed to add to, which is 2 and 3. So we've reached the full length that we're allowed to have. So because of this, now we're going to say this max right here is going to be currently equal to 0, because right now we don't have any max value. So we're going to compare our 0 with our 5. Which number is bigger? That's obviously going to be 5. So we're going to move that 5 right over here. And then we're going to delete our current, and we're going to start the process all over again. So right after this, we're going to move that start over by 1. And we're going to do it again. So same kind of thing. We have our first value, and we're going to take that value here, that current as you saw, we're going to subtract that. So we had 5. We're going to subtract 5 minus 2. So right now our current value is going to be 3. So since our array size is still not larger than our 2 distinct k characters, our current window is not the size of 2 distinct k characters, we can now move the end of our sliding window up by 1. So let's delete that and move it up by 1. So with that, we now see 4 plus 3. So we're going to add 4 plus 3. 4 plus 3 is 7. So because we've now reached the length that our sliding window is allowed to be, which is 2, we're now going to compare 5 and 7. 5 is not bigger than 7, so 7 is now going to be our current max. Okay, so same kind of thing. Our current, we're going to subtract start. 7 minus 3 is going to be 4. And we're going to move that start up by 1. Okay. And so you kind of get the point. We're going to do the same thing. We're going to move this again by 1. That's going to make this equal to 10. And then same kind of deal. So we're going to compare 10 and 7. 10 is bigger than 7, so 10 is our new max. Same thing, move the start up 1. And instead of the same, subtract that, which is now going to be 6. But we're going to just keep it blank for now because we're going to change it. But just know that current is now 6. We still don't have our k distinct characters. We only have 1. So we move that up again, and that's going to equal, we're going to add that to our current, which is going to be 11. 11 is bigger than 10, so we're going to change that out. And because we've reached the end of our array, we now know that our max value is going to be equal to 11. So first I'm just going to delete some of this stuff right here. Just erase that. So all we've done with our window is go from here to here to here and then to here. So we just slided it across to get our max value, which is 11. Alrighty, so first things first, we're just going to create our function, which is just going to be max sub array. And inside we're going to have our k and our array. And then what we're going to do is we're going to set our variable that will hold our maximum sum, which is going to be max sum. We're also going to set our variable that will hold our new comparison sum, which is just going to be called current sum. We're going to set those both equal to 0. Next, we're going to set our window start to index of 0. So start is going to equal 0. Oops. Now, we're going to iterate over the array. So for end, which as we said before is going to start at 0, in range, length, array. So what we're going to do here is we're going to set our current sum plus equal array end. So this is going to add that end value into our current sum. So now we're going to set our if condition that's going to set when we reach our size limit of k. So if end greater than or equal to k minus 1. And so the reason that this is because start is always going to equal 0. And k minus 1, so if k is 2, 2 is going to be 2 minus 1, which is going to be 1, so that's 2 values, which is 0 and 1. What we're going to do here is we're going to do our max sum. We're going to set that right now. Max sum is going to be equal to max sum versus the current sum. So we're just going to compare our current sum to our max sum, which is 0. So whatever this current sum is on the first iteration is going to become our largest, or it's going to become our new max sum. So after that, we're going to set our current sum minus equal array start. So we're going to get rid of that starting value. We're going to delete it from it because our end value is now going to become our new start value. So we're going to get rid of that old start, and that's going to make it so that we already have that added into our current sum. So then we're going to set the new start to the next indice in the array, which is going to be start plus equal 1. And at the end, we're just going to return max sum. We're just going to paste in our test values right here, save, and let's run it. And boom, max sum of subarray of size k equals 9. That's the basics of using the sliding window approach. If you enjoyed the video, please subscribe to my channel for more tutorials and how-tos. Thanks for watching and see you next time.